Hello, welcome to Maths with EJD. In this video, I'll be talking about Python functions and modules, Python functions and modules. And of course, I like to start from this screen so I can show you how to navigate there in case this is your first time. Also, don't forget that you can always download all the notes, all the Jupyter notebooks I've used so far up to this particular one. This is the seventh video in the series of scientific computing with Python. So you can always check the description area to find the link to the Jupyter notes. And the essence of that is so that you can always practicalize whatever I'm doing. So, I mean, I found out that the best way to learn anything relating to coding, like Python or any other language, is to actually code, like is to actually do it. Copy something that works and tweak and change figures, do anything you're curious about, just play with it and see how it turns out so you can know how it works, and over time you can actually build yourself up in this area. So today we're talking about Python functions and modules. So I share my screen. I make sure I share the whole screen so that you see how I move. Okay, this is my desktop, and afterwards I move to my search because I always use Jupyter Notebook. You can see, I can easily see that. But if you don't see it, you can just type Jupyter Notebook there so you can find it and click on that on that. And then this black thing comes up. It's always the first thing that shows up. But the temptation is that you think, what are you going to do with that? And you close it. But once you close it, you won't be able to do anything again. So the best thing is just leave it. And then this web page looking thing comes up. And from here now, this is actually Jupyter Notebook opening. And then you have all the documents you have in every place on your computer, all the folders. So my scientific computing with Python is on the desktop. So I click on desktop and I go straight to scientific computing with Python. And today we are talking about Python functions and modules, and I click on that. So to have access to this, in fact, before you start, before you continue with this video, you can even just go to the description box and get the link, look at the link, click on it. Once you click on it, you find all these documents up to this note on Python functions and modules. And you can even walk along with me as I'm talking. You can check out these things I'm doing and, begin to tweak those things so you can actually get to have better understanding of the things I'll be talking about. Okay, so Python functions and modules. First of all, you need to understand that functions and modules play a crucial role in organizing and implementing scientific computations effectively. So it's all about organization. It's all about arranging your code. And then together, Python functions and modules empower developers to create scalable, well-structured, and easily maintainable code bases, So sometimes you get to do the same duty over and over again. So functions can help you to declare it, and each time you need it, you just call it, and then you keep going. Okay. So talking about functions now, functions in Python encapsulate reusable pieces of code that can be called with specific inputs, executing a set of operations, and often returning a result. And then functions promote modular programming, enhancing code readability, reusability, maintainability by breaking down complex tasks into smaller, manageable units. So I'll give some examples of functions you can come across. I mean, the beautiful thing about function is that you can create your own function. That's the interesting thing about functions. And to create a function, right? Let's look at this first example, which is we want to create an addition function. So you have def. Def is the keyword anytime you want to define a function. So this def is the keyword, and then add numbers. This def is in green, right? Like, so it's a Python keyword. And then add numbers could actually be anything. You can just say it's sum, you can say anything. So that is your function name, and you're at liberty to choose whatever. But def is constant. That's the first thing you have to use anytime you want to define a function. And then A and B are your parameters. They are your parameters. That is, you need to insert a value for A and a value for B when you're calling this function. And then what this function does is that it returns the sum of A and B. So, okay, let me put the line so you can see, I can refer to them by line. So you see line 2 is where the function is defined. If I push it down now, it becomes line 3. Line 3 is where the function is defined. Line 2 and 3. Now you see that just like when we talked about control statement, control flow, right? Anytime you have an if statement, and it ends with a full colon dot dot, and then by once you click enter, the next line goes to four spaces. I mean four spaces after the beginning, right? To show that that thing actually belongs to the function. So in this case, now return A plus B belongs to this function you have defined here. So in lines 3 and 4, you have defined the function. Now, what is happening in line 6 is that you are you are replacing the parameters defined here, A and B. You are replacing them with arguments, and these arguments can vary based on whatever you want. Okay, so here now you have a variable name called results. That's just a name. You're at liberty. You can call it RAS if you like. But then to call the function itself, you have to use the function name. So it's more like you're copying this particular part in that line 3. So add numbers A, B, but then you now change the A to 3 and B to 5. And it is expected to return A plus B, which is 8, right? So that by the time you run this code now, you have print result of addition will give you the result you have here. This result of addition is a string now. So anything you put in a string comes out just like that. So if I run this now, I just get result of addition 8 because we have added 3 and 5. Result of addition is 8 like that. Okay. So of course, you can always define whatever you want. You can define anything. Okay. For instance, let me do something in line with addition still. Or I mean, yeah, let me just create something. Create a new cell that I just copy and paste that, right? And I say add numbers A. So I now say A, B, C. Can I do 3? I'm not sure, but I think I should be able to. So that we now have A squared, return A squared plus B squared. If this doesn't work, I'll just leave it. A squared, okay, say plus AB plus AB plus B, something like this. So then it means I need to say result, add numbers 3, 5, 7, right? And then I run that. Okay, this doesn't work. Oh, okay, I did not complete this. Okay, this didn't have to be there. So I run this now. And okay, still name AB is not defined. Okay, because I need to put a multiplication sign in between because I'm multiplying. Yes, and that works perfectly. So that is 3 squared, which is 9. 3 times 5, that's 15. 9 plus 15, that's 36, right? 3 squared 9. 8 times b, that's 15, that's 24. 24 plus 49. So we have, oh, it looks like that's not working. Only b squared is working. What is the problem here? Okay, okay, because I still said b squared. What if I say c squared? Yeah, that should change now. So I said a squared plus ab plus c squared. That means 3 squared, that's 9, plus 15, that's 24. 24 plus 49 should be 73, I think. And that is what we have exactly. So you can actually define your own function. That's the beauty of functions. So if you have to do this kind of calculation several times in your code, so you just define the function once, and anytime you need it, you can just call it. You can take this out now. You can take this out, and just say, okay, maybe I can even change the code name, right? Let's say uh uh define add, okay, let me just say add sq or add square, anything. I'm just giving it a name. So let me just say add sq. So here you have add underscore sq. So just maintain the name. So, I mean, you could just take this particular part out. You don't have to even call it result. You can call it, let's say we can call it answer, right? So just make sure anywhere you call it answer, just say answer. So I can copy this out now and create a new cell. As far as the function had been declared before, I just paste this. Then I just have answer, add, okay, maybe this is answer. Maybe I call this answer 1, and then I can call this answer 2, and I want it to have to be for 5, 7, and 9, 5, 7, and 9. As far as the function had been declared before, anytime you call this, it will see this add underscore sq as the same thing you defined before. So now this is going to be 5 square, which is 25. 25 plus 35, that is 60. 60 plus 81, that's 141 or so, I think. Answer, okay. Oh, okay. Name at squared is not the at underscore. Okay, because I've not run it again. So this, yeah. So because when I changed the name, I did not run it. So okay, because this is answer one. So many things happening at the same time. Okay, now it works. And then if I come to answer two, then this one is recognized now. So I can just say print answer two straight without writing the story. Print answer two. So that's going to give me 141 or so. Yeah. That's what we get there. All right. So you can define any function you like. So let's come to factorial function. As you know already, factorial is you adding from a number and it is the product of a number and every number after it reduced by one. That is, if you start with 7, it means you have 7 times 6 times 5 times 4 times 3 times 2 times 1. So if you have the factorial function, you say define factorial n. That is so def is the keyword you have to use to define the function. Factorial now is the name of the function, and n is the parameter you're defining. And it's now a conditional statement. So if n is equal to 0, if n is equal to 0, then you return 1 because n factorial, I mean 0 factorial is 1. So if n is equal to 0, then you return 1. Else, you have to multiply n by the factorial of n minus 1. And then, so for instance, if I start with 5, so 5 is not 0, so it won't return 1. So it's just a 5 times, so it goes again. So it's 5 times 4, so it takes 4 down there again, and it keeps going like that until you get the result. So like 5 factorial, we expect 5 factorial to be 120. So if you run that, you get 120. So you can actually copy this out, go to another cell. You can even go to 1,000 cells away as far as that function has been run. So maybe you now need factorial 15, and then you can, so to now be factorial 15 result. So you run this now, and that gives you that plenty value. So once you define a function once in a cell, you can go like 1 million cells after. As far as you're working in the same Jupyter notebook at that time, you can go elsewhere and check it out. Okay, so let's talk about a palindrome. Interestingly, a palindrome is a word that is the same whether you spell it from the front or from the back. So there are many examples like that. So example will be something like wow, WOW. That is a palindrome. Madam, MADAM, from the front or from the back, it's the same madam. Okay. So we want to define a function to check if a word is a palindrome, right? So if I say, so of course, the def is always there. Anytime you want to define a function, no argument, you have to start with DEF. But that's the keyword for defining a function. Then here is palindrome is now our keyword, is now our function name. And the word is actually a parameter which you can which will be replaced later with whatever argument you like to put. So you now say return word is equal to word. Now, the way to reverse something from the back is to put two double quotes. In fact, let me demonstrate that down here. If I come here and I say, so I want to print my name from the back, right? So I say print Emmanuel, or let me use all small letters. Print Emmanuel, or let me make the L last, right? Print Emmanuel, and then I have this double quotes, then minus one. Okay, now okay, maybe I should put it this way. I have a name, and I say, so I just put my name there. Okay, so I have my name there. So here I just come and say print name like that without this. Okay. So it means I want the name to be spelled from the back. So if I say print double column, uh, 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 full column in two places, the minus one, that means from the back. Minus one is from the back. So if I click on this now, you can see my name is spelled from back. It's now Leonam. Interesting. Looks like a nice name though. Never thought about this. Leonam. Maybe looks like a French name or something. I'm not sure. So, like that. So if you want to read from something from the back, that's how to go about that. Okay. So here now, so return word if the word is the same as if the normal word is actually the same word when it is spelled from the back. So that's what this function is returning. It is returning the word if it's the same when it is spelled from the back. So we now say now we have a word called radar. So we now say if it's palindrome word, so print word is a palindrome. That is if this is true. So print that is a palindrome, else print that the word is not a palindrome. For instance, you have put radar. So if you run this now, it tells you radar is a palindrome. So I copy this now. Okay, well, I don't even have to copy this. All I just need to copy is this part where you call the function. So once you define the function, you don't have to carry it everywhere you go anymore. So here I come now. So I now say, maybe the word now is radars. Okay, I just add S to that. So if I run this now, it's going to tell me it's not a palindrome because radars is different from Shradar, it's totally different. So let's check Madame. Let's check Madame. So I click on this and I have Madam, Madam, which is obviously a palindrome. So if I click on that, it tells me Madam is a palindrome. And that goes like that. Okay. So that's that about palindromes. So let's talk about square root function using Newton method. One of the things I'm going to do here is I'm going to do some mathematical things like using Newton method or Jacobi and all these things we do in mathematics because this is scientific computing. So we want to learn different techniques in solving different kinds of problems. Okay, so here we are just get crashing into some of these ideas. So want to find square roots using Newton method, and Newton method is a very interesting method, right? You do it by it's a kind of approximation method, so where you find derivative and all of those things. So here we define the function. We start with the keyword, and the function name is square roots, and n is whatever value number whose square root you're looking for. And then we now have approximate n over 2. That is whatever number we have divided by 2. So now say while true. So you're looking for something better that where the approximation plus the n you have divided by approximate. That's the procedure for Newton method. Divided by 2. If the absolute value of the value now gets as approximated value minus beta is less than, this is now the tolerance limit now. That's something very small to show to the degree of accuracy you want to determine how small this number should be. So if I want less degree of accuracy, I can just make it like 0.001. But here we want a very high degree of accuracy where the tolerance is less than, I think, 1, 2, 3, like 10 raised per minus 6. So return beta if it is better, then finally now just say approx is equal to beta. So in that case, if you want to find the square root of 25, you just say result equals square root of 25, and then that gives us 5, it's an approximation. So these two lines 11, you define the function from lines 3 to 9, and you can call it using lines 11 and 12. So we can just copy 11 and 12 out elsewhere, and we just say we want the square root of, say, 17, and, the square root of 17 should be something like 4 point something. So square root of 17 now has to be 4 point something. So if I run this, it's 4.123, blah, blah, blah. So that's how that works. Then we go to another interesting thing. That's Fibonacci series Fibonacci series function. Now, the Fibonacci series is such an interesting pattern, and it has wide applications in different areas. Even leaves. Yeah, I mean, one popular thing in math is the idea of golden ratio, and people use that to measure beauty. How smooth someone's nose is, or how well shaped a leaf is, and things like that. And all of these things have relationship with Fibonacci sequence and golden ratio. So, and Fibonacci sequence is simply a sequence such that you start with 0 and 1, and everything that follows is the sum of the 0 and 1. I mean, every number is the sum of the previous two numbers. So if you start with 0 and 1, so 0 plus 1 is 1. So you have 0, 1, 1. Then 1 plus 1, 2. Then 2 plus 1, 3. 3 plus 2, 5. And it keeps going like that. That's the idea of Fibonacci. So to define that, we have the keyword def, and the function name is Fibonacci. N is the parameter, which we can change. So if you don't want the Fibonacci, the first 10 Fibonacci numbers, you just put 10 there and so on. So here you say Fib series, you declare, like this, some kind of initialization where you declare 0, 1. Those are the two numbers it starts with. So you now say for I in range. So we've done this fourth thing in the previous video. If you have not seen that, you can refer to that when we talked about Python control flows. So for I in range 2 to n plus 1, so it means so you already have 0 and 1. So from 2, to n plus 1, whatever n you choose, because if you have n to be 10, for instance, you have 10 plus 1, 11. Because Python starts from where you start from, but it stops a step short of where you're going to. So if you're going to 10, you have to make the upper limit here 11 because it will stop at 10. So you now say fifth series dot append. So it means append, like we already know from list previously, to append is to add something to what we already have. So you now say fifth series minus 1, that's counting from the back, plus fifth series minus 2. So this is like minus 1 minus 2. So you're adding these two to get the next thing. So you're now returning fib series. Okay, so if you want the Fibonacci of 10, you just run this. So you have 0 plus 1, 1, 1 plus 1, 2, 1 plus 2, 3, 2 plus 3, 5, 3 plus 5, 8, 5 plus 8, 13, 8 plus 13, 21, 13 plus 21, 34, 21 plus 34, 55. And it can keep going like that. So you declare the Fibonacci function from lines 3 to 7, while you call the function from line 9 to 10. So we can copy that out, create a new cell, and so let's say you want something really big, like maybe you want Fibonacci 50. Not Fibonacci 50, so it keeps going. So you see the number begins to escalate so fast, it gets really big along the line, So that's how Fibonacci goes. And that takes us to the end of functions in Python. So that's just an icing. I mean, that's just an intro to it. So with what we have explained so far as functions are concerned, you can begin to create your own function. So if you need to do, so I mean, you should practice creating functions. You can create functions to do anything, maybe to calculate, maybe you always have to calculate the area of a triangle or the area of a sphere or whatever it is you need to do, or some routine that even involves names. You can see we did something with palindrome. So if there's something you need to do, you can just create a function to always automate that process. Okay. All right. So we go to modules now. Modules and functions they're a bit close, except that modules in Python are files containing Python code. So it means in a module, you can have functions, right? So modules in Python are files containing code, including functions, classes, and variables that can be imported into other Python scripts. You already know the idea of functions. I mean, from what I said already, you already knew the idea of variables. I mean, though I didn't take time to explain variables in particular, but in Python, there are ways of creating variables, of naming variables. You don't name variables using Python keywords like import, anything that appears in green that you have seen so far, import, def, all those keywords, you don't use them as Python variable names. And you don't start variable names with numbers, you start with only letters, right? So, of course, and classes along the line, I think we should talk about classes because classes are objects. The classes come under object-oriented programming. I'm not sure if we're going to talk about that. We get to do that a lot under the data analysis program I teach at BDOT. So that's on. If you want to know data analysis, you can actually enroll. The next class is going to start by June the 1st. So I mean, you still have time to apply before Saturday. So modules in Python are files containing Python code, including functions, classes, and variables that can be imported into other Python scripts. They help organize code into logical units, facilitate code reuse, and support modular programming, enhance code readability and maintainability. All right. So let's take a look at some possible modules. Now, most of the times when you want to use Python, right? Python whatever you use in Python is determined by what you want to do. For instance, I think I said it when we start in the first video on scientific computing. So if you want to do data analysis, you'll be talking about NumPy and Pandas. If you want to do web design, you'll be talking about Django, Flask, and all those. If you want to do machine learning, you're talking about scikit-learn and PyTorch and all that. But for scientific computing, you'll be talking about NumPy, SciPy, SymPy, and all that. So, and of course, as we go on, I will touching on these areas of scientific computing. So, so modules are actually some of those things you need to use to actually do things around Python in Python, right? So here now, let's look at okay, modules help organize code into logical units, facilitate code reuse, and support modular programming, enhancing code readability and maintainability, just like functions. The only thing is that functions are things you define to make your life easy, but modules contain variables, functions, classes, and all of these things. So For instance, we have inbuilt modules in Python and like all these things we are going to have now. You can actually create your own module. So like you define your functions and put them together and you can create a module like that, and all of this scale up to packages and all that in Python, libraries and packages. So here in line 3, we are importing the so you import modules, right? So there's a module called math in Python. So you say import math, and what math does for you is math contains certain functions that you cannot access of their own accord. For instance, if you want to if you need pi, if you need square roots, if you need cos, you don't just get cos like that. You need to get cos from that module. So it means pi and cos and square root are functions inside of the math module. Okay. So here now, line 5 says print value of pi. But instead of, if you say just pi, you won't get anything. But you can only call pi from the math module. You can only find square root from the math module. You can only find cos from the math module. So of course, pi is 22/7 or 3.14, blah, blah, blah. Then square root of 4 is 16, right? But you can't just say sqrt. You have to call sqrt from math. So that's why I say math.sqrt, math.pi, math.cos. Cos 0 is 1, as we know. So if you run this now, you get all those values. 3.14, blah, blah. Square root of 16, that's 4. Cos of 0 is 1. But then if I remove the maths, pi cannot happen. That will give me an error. It tells you that name pi is not defined because pi does not exist on its own. It only comes from the maths module. And that's why you need modules, right? So, of course, we also have the random module, import random. I mean, there's a random module in Python. So if you need random numbers, there was a time, I mean, two of my friends and I, we wrote a paper, or I think we're four on the paper, right? We wrote a paper on, the possibility of human beings generating random numbers without bias. I mean, that's a difficult thing, right? Because, if you ask any random person, like if you ask me for a random number, I'll most likely tell you something like 1 or 7. After that, I can tell you like 10 or 3 because of my personal the way I'm configured. So it's really difficult for human beings to generate random numbers like that. But I mean with Python you can generate random numbers. For instance, people that do raffle draw or you want to give a gift to any random person and those all you just need to do is number them. Once you number them, just bring it here. Maybe the people are numbered 1 to 100 and then you just print random number between 1 and 100. So because it's random, right? You just click on it, tells you 17. So the 17 gets the prize. So since we've imported random, then we don't have to keep importing it in subsequent places. For instance, what if in a class now they have matric numbers? I remember in my undergraduate days, right? Our matric numbers were something like 6 5 something. So let's say we want maybe the beginning is 6 6 4 4. Let's say 6440. That's the beginning, and it goes as far as 6580. I just want to give a gift to any random person in my class, 6440, right? And then it ends at, I'm not sure, this is not, I mean, I'm just guessing, but I know it's 6465 like that. So we just want to give something to a random person in class. So all you just need to do is, of course, you have import random, and random number here is just a variable name. Random.random rand int is actually, so the rand int, that's random integer, is coming from the random module. So this is a function coming from the random module, and that's what gets the job done. So I just want to give a price to somebody in the class, any random person. So I put the interval 6440, the first matric number to the last one, and then I just run it, and it tells me the person that gets the prize is 6495. So if you need to do raffle draws or whatever that requires randomness, you can always come to Python and get it done easily. And nobody will accuse you of ojoro or of cheating. That's the idea. Okay. Then we have the date time module, which is also an inbuilt module in Python. So you just say import date time. And what are the functions you can get from that? You can get today's date from that, and you can also get the time, the current time from that. Of course, that will be based on the time on your computer. So if whatever time you have on your computer is what this is going to give you. So right now where I am, my time is 12:10 a.m. on the 28th of May, 2024. So I say current date is date time dot day dot today. And so the key thing is that we are calling today's date from date time. That's where you can get it from. And the current time, that's date time dot now dot time from the date time package. And if you run that now, it tells me that my date is 28th May 2024. That's the date here now. And then the time is 11 minutes past 12 in the night, 12 in the morning, early morning, right? It even gives the seconds even has some extra on top, right? So you have 3 seconds, 2, 6, 1, 8, 9, 1, like that. So if I run it again, you discover that the seconds will update at least. So you can see it's now 27 seconds like that, So that's that. Therefore, system experts, system engineers also, or system analysts, there's also the OS module with which you can interact with the computer system. Maybe you want to talk about directory and everything. So you have the operating system thing there. So if you want to know the current directory where my module is now, so you can just say from OS now you're going to get CWD, maybe current working directory. I suspect maybe that's not it, but I think I suspect CWD should be you want to get current working directory, like that. And line six, then you now print current directory is that, the current directory here is actually a variable name. And the one here is just a string. And then you call that variable name and it tells you the current directory I'm working in. And then if you also want to see the files in the directory, so it's the files in directory, you just say os.list directory. So that's listdir. And all this you can only call from OS. If you remove OS, they cannot be accessible anymore. Then you can now print files in current directory and you have files in directory, and that's what you get. So it tells me, okay, let me suppress this first of all, so we can see the first thing. So I run this. Of course, to suppress something is to use the hash sign. If you use the hash symbol, you are commenting it, you are suppressing it from running. So if I run this now, it just gives me the first thing. So it tells me this is the directory where what I'm doing currently. This is the directory where it is. So if I now want to see all the other files in that directory, I just run this and it shows me all the files. These are the files in the directory. So then we finally go to a JSON module. Actually, if you're working with data analysis, if you're doing data analysis with Python, you'll discover that you can read Excel files, you can read CSV files. CSV files are comma separated values. You can also read TSV files, that's tab separated values. Then you can read, then when data begins to get very large, you can begin to use things like JSON because they are lighter. For instance, CSV is more compact than Excel. If you are dealing with large data, and then of course as you advance you can go to things like JSON. So we just want to import the JSON module here and do some stuff. So we want to have Python object dictionary to JSON string. So we have person. So of course I didn't worry too much about dictionary when I was talking about Python data structure, variable data structures. So body is I think we've had an example of that afterwards. So a dictionary is simply a value, a key value pair. So the key here will be name. The value is John. The key here is age. Value is 30. The key here is 60, city, and value is New York. So name, age, city, they are the keys. And the values are John, 30, and New York, which are answers to those keys, right? So you now say person underscore JSON. This is a variable name now. It's now JSON.dumps person. All right. And then print person, JSON person. So you now say JSON string to Python object. So it's more like you're converting a string to a Python object now, which is a dictionary. So now say person dict is JSON.loads. So I mean, it may look all complicated, but I mean, we're just basically selling the idea of modules in Python. And with this, we've come to the end of this video. If you are not subscribed yet, you'll be missing a lot. So please subscribe now so that, and of course, hit the notification bell. So whenever I upload a new video, you can get alerted. And as it's dropping, you can get learning immediately. And of course, don't forget to comment, like, and share because other people will find this very useful. Thank you so much for coming this far. Um, till I come your way again, stay glued to this channel. See you in the next video.